Thanks again for joining today's session. We're going to talk through API-driven security automation, specifically for AKS, and we're going to use two tools, Falco Talon and Retina. So I'm Nigel. I've recently joined a company called Cloudsmith, but before this I worked with Joseph on the Falco project, and before that we worked on Project Calico, the CNI for Kubernetes. So without introducing Joseph here, I'm just going to let you jump straight into what is Retina.
All right, thanks Nigel. Hi everyone, I'm Joe. I'm a product manager on the Azure Container Networking team at Microsoft. And one of the nice and cool projects that we have been working for some time is Retina open source. So simply Retina is an open source project developed by Microsoft team for container networking observability. It's eBPF based, and it's just to help users, Kubernetes users and container users to observe, debug, and analyze workload traffic. Yeah, I think it's important to highlight that Retina is powering one of the enterprise product in Azure, which is Azure Advanced Container Networking services, which highlights the reliability of the product and the trust it has earned to power and to observe networking in a product and large environments. So going in a very high level architecture, simply Retina collects metrics from the node where it's running on and send it over to another tool to be visualized using whether it's Prometheus, Grafana, even we integrate with Hubble, so we have Hubble UI. And so this data gets collected by running a program on the kernel level using custom eBPF plugins. And this, so simply Retina designed to be very pluggable. Like if you have a use case that is not really there in the product today, you can develop your own plugin. Some of these plugins that we have today, things like, network drops, where you can visualize or get the packet drops and the reason behind these drops, or another plugin for DNS, another plugin for network forward. And and then this data gets enriched with a control plane part, which relies on Hubble open source developed by Cilium, and then this forward to observability part. So that being said, I think these three pillars define and differentiate Retina. First of all, it's an eBPF base. That means that it's around the kernel, high performance, minimum overhead. We also integrate with open source projects like, as I mentioned, Hubble and mainly Hubble. And the other thing is it's a platform agnostic. So Retina designed to run on any platform. We have a demo on Wednesday if you visit the Microsoft booth, where we will show some use cases for running on different clouds, on Amazon or Google Cloud, in addition to Microsoft. It runs on-prem, on Windows, and Linux. That means that you will have a single pane of glass where all your clouds connected or your environments connected to the same observability tool. And lastly, it's a CNI agnostic as well. That means whatever the CNI you have, is it Cilium or Calico or Azure CNI, AWS CNI, it doesn't matter. It just works, and you don't need to change anything in your networking stack. And I think it's a good example of this is we have Hubble today that gives you the network flow logs, and with Retina you can run it anywhere. You don't need Cilium CNI to get Hubble. So once you have Retina enabled, the first thing you get is different layers of metrics. It's all powered by predefined Grafana dashboard, things like DNS dashboard. You will be there, connection drops, TCP connection status. And the other thing is because we use Hubble for the data enrichment, we also make the network flow logs, the Hubble flow logs available. And again, that works in cilium or non-cilium clusters. And the last thing is the packet capture that we make it available with on demand for nodes and for any bot. So yeah, that being said, that was kind of the fundamentals of open source project Retina. I'll hand it over to Nigel to talk about Falco, and then we will see it in action with a demo.
Amazing. So look, I don't want to bore anyone with presentation, but I do think there's a necessary to introduce what we're talking about here. So most people are already aware from the previous session what Falco was, and it's a detection engine for Kubernetes. But what people don't always know is they think of it as just that thing that detects threats and sends metadata or something, an event, off to one of these endpoints. It could be to Slack or syslog, wherever you want to send it to. And that was addressed in the previous session. But then some people are aware that you can plug into things like Falco Sidekick, which is an automation engine, which is a way of, you could use it for automating with functions as a service, or you might want to use it for the graph ability to have a dashboard that's port forwarded. So that's how people use Falco Sidekick today, but it kind of has a gap, and that gap is we want to be able to respond to threats in an appropriate manner. So we decided we had to create a response engine for Falco, and that is where Falco Talon comes into it today. So as you can see here, this is just a general install of Falco, and I'm just saying create a namespace, make sure it's TTY set to true, so it's real-time detections are coming through, and I've enabled that component called Falco Sidekick. I've enabled it, and I've configured the config to say basically I just want to say like a post request. I just want to send whatever to that HTTP endpoint to Falco Talon on 2803 port number. So in that case, it's sending to Talon, but Talon isn't deployed. There's nothing here called Falco Talon. So we have to introduce what it is and what the problem was initially. So with Falco Sidekick, yes, we could, as an automation engine, send all this data to these general services like Lambda, or send it to Tecton or Knative or whatever it is. And that only went so far because, again, you'd still need to do the scripting on your side to know how you're defining these function service, infrastructure as code, automation scripts. Now, there's great benefits in building out your own solution, of like basically having control over defining the actions that you want to build. But when it's building your own solution, you've got to maintain it, and it needs to be standardized of which it is, and if you're building something custom yourself. So there's all these drawbacks of building your own response engine, and that's where you need a kind of a standardized approach. And we wanted to build an API-driven response engine that basically aligns directly with Falco and takes the benefits of Falco, which is taking all that associated metadata and basically using existing API actions so that it's somewhat standard. And that's where we get Falco Talon. So the idea, as we said, there's all these APIs in Kubernetes. Kubernetes is effectively just a giant API engine. So we said, why not just send that metadata to one of these APIs? So you could populate, for instance, an action to take on. So it could be network policy. You could talk to network policy and populate the pod and the associated context. We'll go through this in a second. But that, in short, is what Falco Talon is. It's a no-code, and what I mean by no-code is we're going to write it in YAML the same way we write the Falco rules, so that when an associated rule is triggered, something will happen and you can configure that. So as you see here, I mean, we're just going to continue adding response actions, but we've basically looked at all the existing APIs and said, whether it be, as you can see, most of them are Kubernetes. So we talk to the Kubernetes API, it's already there by default. We can say, if you want to do sigterm action, then you talk to the terminate API. Or if you want to labelize something, when you say kubectl label pod with whatever label you want to add to it, yeah, it's going to do that. So as a response action, you could say, if I get a detection and I detect a pod for whatever namespace, give it a label, or assign it a network policy and tell it what you want it to do. So this way, it's rather than manually creating network policy and hoping that it ever matches, you'll have it match basically in direct connection with the Falco rule. And then as you can see here on the right side, we're saying we can strip all the data from that output. So things like priority tag, source, whatever the pod, the namespace where it generated, take that context and populated that into response action. We're constantly working on making this more reliable solution. So again, sequential actions, making sure it runs in a sequence and making sure there's deduplication so we don't have like things that are going to break our system. And then also generating trace IDs. So again, this can tie into your solutions where you want to look at all of the associated action from that. So on short, and I'm just going to show you this bottom action here, is this was a long version of installing Retina. So we installed Retina, we installed Falco, we installed Falco Talon all via Helm. And when we install this version of Retina, we basically set this annotation set to true. And the reason for doing that is we wanted a response action initially based on annotations. If a certain annotation was assigned to a workload, which could be done as a response action of Talon, then Retina will do a thing. That was basically the idea behind this. And this could all be API driven. So as you can see here, as I said, it's all YAML, so you can define in a rule. I've got on the bottom right corner, I've got a Falco rule out of default. So this looking for terminal shell into container activity. If someone was to shell into that container, a output comes from Falco. We showed earlier that we send it to that endpoint, so we send it to that webhook, and then we want to populate annotation with Retina sh observe. Basically, if it has that annotation, something's going to happen. You could do label as well, and we'll show that in the demo in a second. So in the bottom, we have a Falco rule that says terminal shell and container. In that scenario, anything that isn't in kube system or in the Falco network namespace, it will get this action of annotation of a pod, and that at the top, the annotation pod is basically talking to that API Kubernetes to the annotation API and basically populating it with that context. So this is why we talked about annotation. If we look at the Retina documentation, they have this simple example here where it's basically saying if you have an annotation enabled set to true, then we will do the, advanced observability on pods in those given network namespace that you scoped. So that's just an example of a simple automation process. But the beauty here is rather than you going manually and adding it, which you would never really do, you can have it so that when a security incident happens, specifically on network security incident, which we can detect in our system calls with Falco, then we want to say, give it the annotation so we get that deep visibility scanning through Retina. And that's what this ecosystem starts looking like after a while. So you have Falco, the plugins, you have Falco Sidekick as the automation engine, and then Talon as a response engine where you can send out API actions to things like AWS, Azure, in this case, annotations, labels. You can integrate with just about all your endpoints with the right context. So let's just jump straight into the demo. I think that's probably the best place to go. So we've got a simple AKS cluster ready here. We should have, feel free to go ahead on it. So we should have 3-node cluster. What we're going to try and simulate is a very simple example that I showed there a second ago. We're going to create a pod, and this pod is going to be created into the default network namespace. Actually, it's this TCP client pod that's being created. That should have no real labels associated. I mean, just a default label that's assigned to it, nothing really interesting. And when we trigger the terminal shell, when you say kubectl exec into a pod, when that happens and we shell into it, it should trigger Falco rule. And in real time, we're talking milliseconds, not even a single second. It will add the annotation, it will add the label. You could even assign a network policy. All this can be done instantly. In doing so, and we'll try to do two things. We'll show you, okay, we terminal shelled into that container now. If when you exit, just type in exit now, and then we check for kubectl get events, or if you want to, exactly describe the pod, or get pods and just show show labels. We can see, or just labels with an S. Then you can see at the bottom it's got that suspicious equals true. That wasn't part of the deployment. That actually was assigned instantly when the detection happened with Falco. So again, you're talking to an existing API. There's APIs for labels. There's, you can see here, we even assigned the annotation for Retina sh observe. So doing that, while we don't think about it, Retina's been installed via Helm, Falco's been installed by Helm. That annotation alone has triggered Retina to do all this deep scanning. Basically, think about even the legacy world of Wireshark. You always had to run a capture to get your PCAP file. Well, in this scenario, you're getting your deep capture of all the surrounding context for whatever that time period is in response to a security detection, which is the only meaningful time you want to have that capture. As you can see here, we've done basically get the event output, the log output for Falco Talon. And as you can see here, it's doing, you can actually see the full trace output. So you can see annotate pod, label pod as suspicious. Those are the notifications that are coming out telling us it did something in Talon and it did it in response to something else. So Falco triggered the event and then the associated Talon action is shown in here. So For instance, if it was an incorrectly formatted response action, it didn't work, it would throw error or failed because, you know, you tried doing something that's not formatted correctly. But in this case, info, it came through okay. You can see the actioner, it talked to the Kubernetes exec action, and you can see it talk to, for instance, the Kubernetes label action or the Kubernetes annotation action. All three of those actions actually came in response to one single action. So we can have multiple response actions. Now in a real world scenario, what you would probably do is say, you know, we've seen something happen, label it with whatever label so that network policy is enforced. So therefore, like, outbound connections don't happen if we see a suspicious connection to a C2 server. And then you might also want to have, you know, some form of security observability so we can see when this happened, you know, so we have the surrounding context. Is there anything else you want to add on to that demo? Or did
All right. So yeah, once so basically what Nigel did now, he adds three actions. He adds the label, he adds the annotation, and the other thing he created exec a command into the pod where he creates some IB tables, so to block the inbound traffic. So if we check that, you will see that a table rule has been added to drop all the inbound traffic. So if we go quickly, I don't know. If we go quickly onto, just need to port forward our Grafana dashboard and Hubble flow. All right. So in this environment, this is a non-Cilium cluster, and we have Retina enabled, and we have the annotation in place. So once we can simply use Hubble CLI to observe the network flows in this environment, and we'll start to see the drops that you can see it now. And with the table, with the drop reason, IB table rule has been dropped. So that's the result of the policy that Nigel had just deployed. We can also go to the Grafana dashboard and see if we go to local host, that's fine. So yeah, some of the nice dashboards here, if we can go to the Hubble one, and this is our pod. You start to see here that there is forward traffic has been started to drop, and the drop traffic has started to increase. And that gives you an idea about, okay, what is if there's any drop traffic. So probably you start here with this dashboard to understand if there's any spikes, if there's any change in the behavior of your application in terms of the inbound or outbound or outgoing traffic, if there's any packet drops, and you take it from there. You can visualize, you can do a further analysis with Hubble CLI. Another thing that you can use Retina is one of the nice things is a DNS dashboard, and DNS has always been one of the main issues in Kubernetes world. With this dashboard, you get the most important thing from this dashboard is the DNS errors. So yeah, this cluster needs a lot of fine tuning. So I didn't do anything special in this cluster, but you can understand the different errors you have in the environment here, top DNS queries and top DNS responses from with pod name and deployment name. And one of the good things here is the DNS response table, where you can understand where the errors are coming from. So you can simply understand that there's some misconfiguration in my core DNS that is trying to add maybe the service.cluster.local to any external address I'm trying to resolve, and this is a kind of a known issue that needs some fine tuning in the cluster. The last example I have in this demo is packet capture. So in this environment, we have Retina CLI installed, so we can simply just with one command, let me clear this. So yeah, it's just one command, kubectl retina capture, and you define whether it's a pulse selector, or even you can define the whole node. Destination could be host path, could be external storage, any persistent volume, and then you add the duration. There's a lot of other options. You have it in our documentation, but once you have this, you can simply just download it and use Wireshark to analyze this in your environment. Yeah, probably the job is not completed, but I think that was it. We are happy to get your questions if you have any.
Any questions? Going once? Going twice? Think about it. I have a question for you.
Okay.
In the beginning, you talked about Retina and that it hooks into eBPF. And I think you said it's pluggable, and there was Inspector Gadget there. Yeah. Can you expand a little bit on that?
Yeah, we use an Inspector Gadget underneath to collect some of the metrics, or some of the plugins use an Inspector Gadget. So at the moment we have a couple of plugins, like the ones I mentioned, like packet drops or packet forward, DNS. We have a specific plugins to integrate with Hubble and with Cilium. But yeah, an Inspector Gadget as an open source project we use underneath as well to collect some of these data. We use the binary of the Inspector Gadget, but because we use it, we have to just declare it. Yeah.
And does it mean it's the only eBPF source that you're gonna use?
No, no. You can. It's very customizable. You can build your own eBPF library and you just use it to hook to any part in the kernel and get these data.
Have you looked at using Tetragon, for example, also mentioned in the previous talk?
Yeah, it's it's one of the things that for runtime security, we don't have any plugins yet, but yeah, we are happy if anyone wants to write a plugin or contribute to the project. That would be great, and we can help as well.
Sounds good. And if anybody has questions, how to use it, how to set it up, how to get it up and running, where do they go?
Yeah, they can go just to retina.sh or GitHub Microsoft Retina, and they can reach out directly if you want on LinkedIn. We're available during KubeCon and Boost in 150. So yeah, that's how to reach out to us.
Sounds like you can do more demos there, right?
Sure.
Okay, awesome. Any questions? Any additional questions? If not, thank you, Nigel. Thank you, Joe.
Thank you.
And it's another break.